Hello again everybody, Tin Man here once again. As you know, I've been doing some experimenting on pulse motors, trying to get the best efficiency that we can. I decided to have another little play around with my window motor you might have seen in the video a bit earlier on. It sort of got neglected a bit once I finished it because I started on the pulse motor systems. But I decided to switch over to this one because this one was already running fairly efficient. Now I've changed the circuit on it. I was using the Bedini SSG circuit on it. It's now a combination of my single battery circuit that I made a few months ago and the one that we've been experimenting with on our pulse motors under the pulse motor tunes section on the TEEP forum. Now the really interesting thing about this now is it's performing quite well. I've been using these 3.8 volt cells out of a battery drill. One of the cells dropped out, so I pulled it apart and rescued the other 9 that were good in it. They're a 3.8 volt cell. Like I said, there was 10 of them in the drill. It was an 18 volt drill. And the reason I like using these, we can flatten them right out and charge them up, and they don't mind that at all. I just hook up, I've got this, it's a 12 volt light globe, 35 watts out of a car. I'll just use that to run the batteries down. Pulls them down in about half an hour, so not too harsh on them. Now I've got this one here as my charge battery. This one at the back's my run battery, and all I've done is soldered some little neo magnets onto the wires so I can change the batteries over easily. Now with this system here, as you might know, this LED that's on here, on the SSG circuits we've been working on, I've put diodes across the trigger coil, and this power is actually coming off one side of that trigger coil that used to go back to the negative side of the run battery. So I just want you to see that light is in fact quite bright. Now the coil, as you would have known, is out of a microwave. I've just split it in half. The trigger coil is 39 ohms, and that's the inside half of the coil. The outside half of the coil is our run coil. That's at 41 ohms. So the ohms are very high, which is why we're getting a very high voltage back off half the side of the trigger coil. Now the other thing I've been thinking of was we've been collecting the back EMF from the collapsing run coil on these pulse motors, and we've all seemed to have forgotten that you'll get the same amount of back EMF from the trigger coil as well, because that collapses at the same speed, same time as the run coil. So it's very messy. I've also incorporated the back EMF of the trigger coil to be pumped back into the run battery. As you can see, I've got diodes and resistors and crap everywhere. Now, like I said, this is running on 3.8 volts at the moment, but it's trimmed down 6.2k between the trigger coil and the base, and it could still even go down more. That pot's turned right down to the full 5k, and then I've got 2 resistors which add up to the 1.2k. Need to put a 10k pot on there. There's the bridge there across, or the 2 rectifiers on the trigger coil, and I've put a resistor across one of those rectifiers which is driving that. And also in here I've got another 4007, which is, oh, the rotors just fell out. Got to be very careful with these magnetic bearings because they're only just in. So that's a bit tricky. I haven't fixed the coil down either, so that's not helping us much. So I'll just get it going again. Yeah, so I put a diode 4007 like we do in our run coil, which is pumping voltage back into the run battery as well. So this wire to the run battery, that's soldered on, and that run battery's been on there since I've started mucking around with this circuit. Now here's the real neat thing. So far it's charged 3 of these batteries to 4.3 and 4.03 and 4.04 volts. Now I've been tallying this up on our paper here. The run start voltage of our run battery was 4.03 volts. The first charge battery after I'd flattened it down was 1.37 volts. Our second charge battery was 1.761, our third charge battery was 1.56, and I'm on our fourth one now, which started at 1.319. So far it's charged 3 batteries, and as you can see, that one's 4.04, that one's 4.03, 4.04, and this one here is 4.03, 4.04. Now this is not a surface charge that's in these batteries. These batteries have either been charged or they haven't. Like I said, that's a 12 volt globe, 35 watts. And as you can see, if that was a surface charge, it would be dying in the arse very quick. But these batteries are fully charged. Fourth one on the system at the moment. It has 3.82, 3.83 volts in it. Now that's been going for about 3.5 hours. The first battery charged up in 5 hours, so I've made each charging of the charged battery 5 hours long, just to keep them all exactly the same. Now here's the really interesting bit. This run battery has not been charged since I started. Now there's no point in cheating or trying to falsify anything with this, because you're only cheating yourself in the end. But I want you to have a look at the battery voltage in the run battery. 4.04, 4.03. It started at 4.03. This battery voltage has not dropped, and it's charged 3 batteries so far, and it's already well up over halfway of charging that battery. So this thing here at the moment, with my mess I've got here, is, I would have to say, the best I've had anything working so far. And also keeping to account that we're also driving this LED. It's a 2.5 volt 35 milliamp LED, a green one, nice pretty green. I do have 2 yellow ones that you would have seen the same, that are hooked up in series on the pulse motor to show you the power that this was running off in one of my previous videos. So there was one other thing. See if I can carefully turn this around without the rotor jumping out again. Now I'll just see if I can zoom in a little bit on it, because this is fairly faint. Here we have our neon, 110 volt neon. Now it's not very bright because we're only on 3.8 volts or 4.03. as you would have seen, but however it does just light up. I don't know if you can see that, but it is just lighting up, and do get a tickle out of that if you touch the wrong thing. So it is just lighting up that 110 volt neon on 4 volts and over 6k of resistance going to the base. So this I'm very happy about. Had to do a video and share it with you guys. I will get to and trace my mess and make a circuit diagram of this, but I believe this has real potential. As you can see, those 3 batteries have been fully charged, all of them, off this one battery, and this hasn't even lost 0.01 of a volt. So working very well. I'll keep you updated on it, see how many more I can charge before I start losing voltage in this, but at the moment it doesn't look like this battery is going to lose any voltage at all. So I'm really happy with that. 3 batteries and 1 well on the way, another hour and a half that one will be cooked, and I've got 1 more flattened out ready to put in, and then I'm just about out of those sort of batteries. So I'm going to try it on the big 12 volts next. I'll have to glue those magnets into the rotor because they're only just wedged in there at the moment, and I've hooked it up to the 12 volts before, and this thing really gets motoring, and a lot of shaft torque on it as well, a lot more than the pulse motor, for a lot less power. So anyway, I'll keep you up to date for sure. Write up the circuit diagram for this, stick it on the forum under my pulse motor part of the forum, which is in the pulse motor section, of course, of the Teep forum. Come over, have a look, and yeah, most happy. Talk to you soon.